Okay, so awesome. Okay, so I'm recording now. Great. So what I was saying was that this is the model that we will be using to run our analysis today. And it is based on the data sets that it came with when the information packet was sent to you yesterday. So the data set is basically about online shoppers and their repurchase intentions. Now, these repurchase intentions are set to be determined by the condition in which the items are when they are delivered to them from the retailer who they purchased it from, as well as the timeliness of the delivery, as in whether the delivery came on time or it was delayed. And then the other return handling policies of the retailer, such that the customer considers whether or not the retailer will accept a return in case they are not happy with the items that they purchased. And ultimately, we also want to see how security and privacy issues mediate the effect of these factors on the buyer's repurchase intention. Because when it comes to buying online, a lot of personal information is exchanged, including the person's name and their address, and sometimes even their payment information may include their credit card numbers or their debit card numbers. So security and privacy is said to be a mediating factor in the effect of these three variables we have talked about on repurchase intention. So that is what our data set is essentially about. So this is our data set. And as you can see, it has items relating to each of the variables that we just identified. So in the data set, we have age group, gender, frequency of shopping online, and then we have OR1 to OR5 representing order return handling. Then we have SP1 to SP6 representing security and privacy. Then we have TD1 to TD4 representing timeliness of delivery. Then we have DC1 to DC5 representing delivery condition. And then we have RI1 to RI4 representing repurchase intention. So these are the variables and the items that represent them in the data sets that we will be using. And as you can see, this is a cloned data set. So already the labels have been replaced with the names of the items. So very quickly, like we know from the beginning, let's go and try and run our factor analysis and extract the pattern matrix model to go and build our measurement model in AMOS. So like we already know, when it comes to building the factor analysis model or the exploratory factor analysis model, we first go to analyze, then we go to dimension reduction, then we go to factor. And once the window opens, we go ahead and we put all the items that are of interest to us into the variables box by clicking and selecting them. So we first select OR1 to OR5, representing order return handling, and put that in the variables box. Then we go ahead and select security and privacy, represented by SP1 to SP6, and we put that in the variables box as well. Then we do TD1 to TD4, representing timeliness of delivery, and we put those in the variables box as well. Then we do DC1 to DC5, representing delivery condition, and then we put those in the variables box as well. Then finally, we pick up RI1 to RI4, representing repurchase intention, then we put those in the variables box as well. Then under descriptives, we select the coefficients, the significance levels, and then the KMO and Bartlett's test of sphericity. Then we click continue. Then under extraction, we select maximum likelihood. Then we leave the extraction method to be based on eigenvalues which are greater than 1. Then we click continue. Then under rotation, we go in for Promax rotation, as we all know. Then we click continue. Now, to be able to make sure that we are getting the output that we need, the maximum likelihood extraction, like we said, always goes with the Promax rotation when we are conducting the EFA to get a pattern matrix to carry through to AMOS. since AMOS operates using maximum likelihood estimation. Now under scores, we do not select anything, so we close that. Then under options, we would want to go ahead and suppress small coefficients to only see those factor loadings that are 0.5 and above. So here we will enter into the absolute value below box, 0.5. Then we click continue. Then after everything has been checked and we are sure we have all that we need selected, we click OK. Now, as soon as we do that, it will open the output window and show us the output from the analysis that we just ran. So as you can see, every single thing that we have selected, that we have indicated that SPSS should compute for us has been computed, including the KMO and Bartlett's test, which we need to check for accuracy and adequacy. And as you can see, the KMO is 0.933, meaning it falls within the threshold that we are looking for, which is between 1 to 10. However, with values of 0.6 and above, we are more than excited. And we also said the Bartlett's test of sphericity has to be significant at 0.00. And indeed, it is significant. So we are okay with this as well. Now, under total variance explained, we need to look at how many factors are going to be extracted based on their eigenvalues. And here we can see that the eigenvalues that are being selected are those factors with eigenvalues greater than 1. And a total of 5 factors have shown eigenvalues greater than 1. And cumulatively, they are explaining a total variance of 81.385%, which is significantly greater than the 50% that is recommended in literature. So here again, we are in excellent hands. Then we go to our pattern matrix, which is of extreme interest to us because that is what we are going to copy and carry through to AMOS to build our measurement model. So here we've seen the pattern matrix. It looks good. It seems all the 5 factors have adequate variables under each of them, with all the measurement items showing values of 0.5 and above. So we just click and copy the pattern matrix model by right-clicking it and selecting copy. Now, once we have done this, we go straight to AMOS to go and paste it in there to build our measurement model. So now we are in the AMOS window. And in the AMOS window, we said the first thing we need to do is to import the data sets that we are working with. So we will use the calendar tab here, which is called select data file. We click on it and it will open the data files tab for us. Now, using the data files tab, we will click file name, which will send us into our computer to look for the data sets that we will be working with. So here, as usual, mine is saved in the folder called UGBS 703. So I enter that file and I go and select our data file, which is the SEM practice file, and I click open. And immediately it is supposed to be imported into the AMOS software by showing in the data file window. And you can see here, it is immediately showing with the name SEM practice file 1 and the total number of items in the file, which is 221. So since we are satisfied with this, we go ahead and we click OK. And now the data is registered in the AMOS memory. So we can go ahead and use the plugin to build the measurement model using the pattern matrix that we copied from the SPSS output window. So to do this, we click plugins. And then in the plugins, we go in search of the pattern matrix model builder and we click on it once. Now, as soon as we do that, the pattern matrix input window opens and we right click in the white space and we paste to paste our pattern matrix that we copied from SPSS into the AMOS window. And then once it is pasted, we go ahead and we click create diagram. And we can see in the bottom right corner when it is working that it is indeed creating the diagram with that yellow box flashing. Now, as soon as it is done working, we will immediately be able to see the pattern matrix model beautifully created for us to go ahead and name. Now, the paper size is currently not optimal for the model that we have. So I'm going to go and expand the paper size to a size that will be able to fit our model properly and aid us in our analysis. So we said we go to view and then we click Interface Properties. And immediately it will open the Interface Properties window. And here we are interested in the paper size. So we click the down arrow and we go in search of Portrait A4. And we click on that, and immediately the paper is adjusted to Portrait Layout A4 size. And then we just close the window to accept the changes. So now that we have fixed the layout of the paper and we have created the model, we now have to name the latent variables or the unobserved variable, looking at the constitution of the observed variables. So here, factor 1, which is the latent unobserved variable here, is represented or constituted of the following observed variables, which are SP1 to SP6. So technically, we can easily name factor 1. And what name would we give to factor 1, please?
Security and privacy.
Exactly, because that is what it represents. So to be able to fit in the box, let's call it SecuPriv. Great. What about factor 2? Looking at its constitution. Factor 2. Factor 2. OR. OR was representing what variable?
Order.
Okay, so that is for order returns, right? So let's
order
make
return handling.
Very good. So let's name it ORDRETU. Next, we have RI, which represents what? What does RI stand for?
Repurchase.
Repurchase intention. So we can call it rep int, right? Good. And then TD represents what? Timeliness of delivery. So we can call it Tim Dell. And then finally, DC represents what? What does DC stand for? What does DC stand for? Delivery condition. Excellent. So we can call it Delicon, right? And then that will fit in beautifully. So now we have our measurement model looking very nice. So technically, everybody should have done this. This was your homework. So right now that we have created the measurement model, we have to go ahead and save it. So we click Save, and then we go and save it. So I'm going to save it as usual in my UGBS 703 folder, and I'm going to call it CFA on. Well, let me reverse. Let me call it on CFA. Yeah, so that is what I am calling mine. So I'm saving it. And now I'm going to close it and then go back to the window and reopen it. So I'm back in my folder where I saved the on CFA AMOS model that I just saved. So I have to go and find it and then come and open it. So this is my on CFA model and I am opening it now. Great. So I have managed to reopen my on CFA model. So I'm going to now go ahead and run the measurement model through the confirmatory factor analysis. Now here we said we have to select the analysis properties that we are looking for. So I'm going to use the piano keys with the colored boxes on it. And I click on that. And I go straight to the output tab and I select the outputs that I'm looking for, starting with the standardized estimates, the squared multiple correlations, the covariances of estimates, the correlations of estimates, and then finally, and most importantly, the modification indices, which are going to help us to prune the model to be able to get it to satisfy the requirements for reliability and validity. So I close this now, and then I go ahead and I run the model. So I click the piano keys that have no colored boxes on them, and immediately you see AMOS starts thinking, and then the red arrow pointing upwards becomes active, meaning that the analysis was successful. So as soon as I click on it, you'll see that the plaintiff figures will appear with the unstandardized path estimates. Then once I click standardized estimates, all the standardized variables come in. So we go to estimates in output to be able to see what the output of the analysis looks like in tabular form. Now, by doing this, we can be able to clearly determine what exactly we are going to do in terms of getting our model to satisfy the requirements for reliability and validity. So this is my output window. And in my output window, I am trying to go to estimates, where we said we will find the various tables that we need. And here under estimates, the first table that we come across is the regression weights table, which shows us the standard errors, the CR values or the T values, and then the P values for each of the measurement items. Then we go to the standardized regression weights table, which shows us the standardized estimates for each of the items representing each of the variables. Now, we said that over here, we are looking to see whether each of the estimates or the loadings is greater than or equal to 0.5. So here, do we have any estimates that is below 0.5? Very quickly. Do we?
No.
No. That means that on this front, we are safe. So the next thing that we are going to do is to look at the model fit. So we go straight to model fit and we begin to assess from the chi-square degrees of freedom ratio. Now, as you can see here, the chi-square degrees of freedom ratio is 3.6. Is this acceptable or not? Is it acceptable or not? Hello?
It should be 2 or 3.
Good. So good. So what we have now is not acceptable. It is above our threshold. So already we know with our chi-square we are in trouble. Now, when we go on to look at the other indices, being the absolute fit indices, we can see that they are also way below the 0.9 mark. Even though if we approximate, we will get to 0.9. The figures that we are seeing, coupled with what we saw at the chi-square degrees of freedom level, means that we are in hot waters. Again, when we scroll down to look at our RMSEA, we can see that it is way above the accepted threshold, which is 0.06 or 0.08. And currently it is 0.109. So we need to do something about it. So what can we use to do something about it? We have to go to our modification indices and start by pruning the extremely high modification indices. So here, when you look through the list of modification indices that we have, which one is the largest? Very quickly, just look through and tell me which one you can see.
E23.
I'm scrolling. It's 63. Yes. Yes, we've gone all the way to the bottom, and 63 is the largest. And that is in relation to E23, isn't it? But it is linked to both E23 and E24, right? So which one do we delete, E23 or E24? If you ask me, because E24 is correlated to more of the actual latent variables, I would want to delete E24 first to be able to see the effect that it has before I go ahead and delete E23. Please, do we understand?
Yes, please.
Good. So we are going back to our interface to go and delete E23. So here we are in the interface. We use our X to delete E23 over here. Sorry, we said E24, right? Sorry. So that's a reverse. We're going to delete E24. So we quickly delete E24 and we rerun the model and we go back to our output. And as soon as we do that, we can see from the model fits that things have improved, right? The chi-square degrees of freedom ratio is now 3.3 instead of the previous 3.6. But the RMSEA is still terrible. The IFIs and the TLI and the CFI have improved a bit, but we are still in hot waters because of the other two fit indices. So we have to go back again to modification indices to do some cleaning up. So immediately we do that, you can see that E23 is now no longer so much of a problem child, but we have other items that are showing high modification indices as well. What is the next largest modification index that you see over here? I see a 36. I see a 34. Okay, so I think the largest currently is the 36.
Yes.
Good,
36.
and that is in relation to E12, right?
Yes.
Yes, so we will go to our interface and delete E12. So we use the X, we delete E12, but E12 is a pack leader. So that means that we have to replace that particular item. So we create a new pack leader for that particular latent variable. So we can go back and rerun the model. So we run it again. We go to our output. We go and look at our model fit. Things are still getting better. Now it's 3.1 instead of 3.3, but the RMSEA still looks bad. So we need to keep going. So we go back to the modification indices and again, look at what the highest figures are. And again, there's another 36 over here, E5. Please, can we see that?
Yes, please.
Yes,
Yeah,
please.
and that is the largest. We don't have any other large one. So we go back to the interface and we delete E5. Let me just confirm.
One is not there.
Is it E5? Yes, it's E5. Great. So we are deleting E5 as well. So we go ahead and we delete E5. Then we rerun the model. Then we go and look at our output again. Look at the model fit. Oh, chi-square degrees of freedom is much better now. It's now at 2.77. RMSEA, however, is 0.09, which is not acceptable. However, our IFI, TLI, and CFI are all now above 0.9. So we are okay on those fronts. We just have to work on getting our RMSEA down. So we go back to the modification indices and still look for the next largest figure. And here we have 34. I see 34 here. I see 31. Yeah, 34 is the largest. And it is in relation to E16. So we go back to our interface and we delete E16. So we use the X and then we delete E16. However, E16 is again a pack leader. So we have to replace it with another pack leader. So right now that we have replaced E16, which was in relation to TD1 with TD2, we can go ahead and rerun the model. Now, as soon as we run it, it will give us a new set of outputs. And looking at our model fit, we can see chi-square has improved again. It's now 2.64. Our RMSEA is now 0.087. We are almost there. So we go back to our modification indices and we again go and look for the largest figure. Here I see 26, 21, 20, 20, 16, and 18. So 26 is the largest so far, and it is in relation to E15. So we go ahead back to our interface and we go and delete E15 like that. Wow. Our dependent variable is almost getting eliminated. Can you see that? Because now it has only 2 items left. Let's pray we do not have to delete any more items from repetitious intention, given that it's our dependent variable. So we go ahead and we run the model again. We check our output and the model fits. Our chi-square degrees of freedom ratio is now 2.5, which is acceptable. Our IFI, TLI, and CFI are all well above 0.9, which is great. And our RMSEA is 0.083, still very close to the borderline. So I think we can delete one more item to improve the modification indices. And here we have 3 different values that are in the 20 range. We have E4 with 20.1, we have E9 with 20.97, and we have E2 with 20.32. And I think the largest here is 20.97, which is related to E9. So we go back to the interface and we delete E9. So we use the X and we delete E9, which is linked to OR3. And then we rerun the model. So as soon as we run it, we go back to our output, we check the model fit, and chi-square has dropped again to 2.3. Our TLI, IFI, and CFI are looking awesome. They are all now in the 0.95 range. And then our RMSE is now down to 0.07. So I think we are okay now. So now that we are set with our model fits, we can now go ahead and check the CR, which is the composite reliability, and the AVE. And to do this, we use the stat tools package, which is where we broke off on Monday. So now we are going to go into the output window and copy the correlations table and come and paste it here. Then we will copy the standardized regression weights table and come and paste it here. Then we will click this red tab to run the analysis to get the CR and AVE values. So very quickly, we go to estimates in the output window. We click on the standardized regression weights. We right click and copy. Then we come and paste it here like this. Then we go ahead back into the output window and copy the correlations table and also come and paste it here. So we right click and then we paste. Then we click the big red tab to calculate. Now fingers crossed, we want everything to go very well. We click on it. And what's the output? Yes! Please, can we see that?
Yes.
We do not have any validity or reliability issues, at least at the convergent level. So we've satisfied reliability and convergent validity because our CR values are all well above 0.7. Yes, Adoma, we made it. Then we have our AVEs all being well above 0.5. You see how satisfying it is when everything goes well. The moment you run it and you see those red numbers, oh, then all of a sudden your heart rate goes high because you know things are not going well. All right, so our CR and AVE values are all excellent. So we can now move on and test for the discriminant validity. And that is where we said to be able to use the Fornell and Lacka criterion, we copy these AVE values and we enter them in the diagonal, and then we copy the correlations and then we enter them off diagonal. So to be able to obtain the correlation values, we have to go ahead and run these correlations in SPSS. But to be able to do so, we have to compute these variables. SPSS does not identify these variables yet because we have not created them. So we are going to go into SPSS and create these variables using the items we have ended up with over here. So as you can see over here, security and privacy is made up of SP1, 2, 3, 4, and 6. Order return is made up of OR1, 2, 4, and 5. Repurchase intention is made up of RI2 and RI3. Timeliness of delivery is made up of TD2, 3, and 4. Then delivery condition is made up of DC1, 2, 3, and 4. So we are going to go back into SPSS, compute them into individual variables, and extract the correlations to build the Fornell and Lacka table to prove discriminant validity. So we quickly go to SPSS, which I have opened here. And then we're going to start the computation. So to be able to compute, yes, Angmosi, go ahead. Angmosi, your hand is up. Please go ahead. Your microphone is on, but I can't hear you.
Hello?
Yes, I can hear you now.
Yes, so I just wanted to ask if you can slow down a bit with us. Trying to follow on the correlations, or I'm just following. I didn't put the names.
I can barely hear you.
Hello?
Hello?
You could slow down a bit with us. Raise some things up.
I still can't. Please, can anyone hear what he's saying? I can't hear him at all. Yeah. Whiteson, we can't hear you at all. So I don't know if you can type it out. Oh, I should slow down. Okay. I went the pace at which I went in the beginning because those are all things we had done previously. So this is where we are picking up for the first time. So I'll slow down at this point for you. All right. So like I was saying, now that we have been able to compute and get the CR and AVE values beautifully like we have here, we are going to try and put these variables together into the discriminant validity table using the Funnell and Laka criteria so that we can be able to test for discriminant validity. Now, to be able to do this, we have to compute these individual variables in SPSS using these items that they are represented by in AMOS. So we are going to go to SPSS and take these items and put them together to represent each of these latent variables. So we go to SPSS and then we take them one after the other. So we will first start with security and privacy, which is made up of SP1, SP2, SP3, SP4, and SP6. So we go into SPSS here, then we click transform. Once we click transform, we click compute variable. Then you will see a huge compute variable dialog box will open up. And this is where we are going to compute each of the items. So we said we were starting with this particular item, which is security and privacy. And it is made up of SP1 to 4 and SP6. So we will enter the desired name we want for it in the target variable box, which is secupriv. Then in the numeric expression box, we find the average of all the individual items that represent the variable. So we create a bracket. So we click here, these brackets, and they will appear in the numeric expression box up there. Are you with me thus far? Are you with me?
Yes, Doc.
Okay. So we are going to find the average of these items, these 5 items. So we have created the brackets. Now we are going to put the 5 items in there, and they include SP1. So we click SP1, we use the arrow to put it in there, then we bring the plus sign. Then we click SP2, then we use the arrow to put it in there, and then we click the plus sign. Then we click SP3, then we use the arrow to introduce it, then we click the plus sign. Then we bring in SP4, then we use the arrow to introduce it, then we click the plus sign. Then we click SP6, then we introduce it. And then since SP6 is the last item, we do not bring the plus sign anymore. Then we go outside of the bracket, and then we introduce the division sign because we are going to find the average. Then we count the number of items in the bracket. And here we have 1, 2, 3, 4, 5 items. So to find the average, we divide everything here by what? 5. So we put the division sign and then we put 5 over there. Then we click OK. Now, as soon as you click OK, you would notice that a new variable is created. And in the output window, it will appear as compute. Secupriv equals, and it will show you the formula that we just put in. Then when you go to the SPSS data file in the variable window, you will see that a new variable has been created called secupriv. And when you go to the data view, you will see that it has data entries all the way to the last respondent in the data view window. Please, can we see that? Please, can we see that?
Yes, please. We can see.
Okay. So we are going to do this for the remainder of the other variables in the model. So we'll continue to order return. And order return is made up of OR1, 2, 4, and 5. So we will go ahead and go into SPSS and compute order return using OR1, 2, 4, and 5. So with the same formula, we click transform, compute variable. Then we reset, right? Because what we did previously is still there. So we reset, and then we enter the target variable name in the target variable box. In this case, it is ORD retu for order return. Then we introduce the bracket again. Then we put in the bracket OR1, 2, 4, and 5 as follows. So OR1, then we introduce it, plus OR2, plus OR4, plus OR5. Then we divide by the number of items in the bracket. So in this case, we bring the division sign, and then we divide by 1, 2, 3, 4. So we introduce the 4, and then we click OK. And immediately you will see that a new variable has been created in the SPSS file. That is ORDRETU. Good, so we've created our second variable. So we'll go ahead and create a third variable, which is repurchase intention. That is made up of RI2, and RI3. So with the same formula, we click transform, compute variable, then we reset. Then we name the target variable, which in this case is rep.int, which is repurchase intention. Then we introduce the brackets, and then we put the items in the brackets, which is RI2 and RI3. And we divide by the number of items in the bracket. So we divide by 1, 2. Then we click OK. In essence, we've created our third variable. Then we go ahead and create the fourth, which is timeliness of delivery, represented by TD2, 3, and 4. So we go into SPSS with the same formula, transform, compute variable, then we reset, then we name the variable, which is timeliness of delivery, Tyndale. Then the numeric expression will be TD2 plus TD3. Yes, we are on course. So TD2 plus TD3 plus TD4. Then we divide by the number of items in the bracket, which is 3. Then we click OK. And these are the 4 items. Then the final item, which is delivery condition, DC 1, 2, 3, and 4. So we go into SPSS, and with the same formula, we transform, compute variable, and then we reset. And we name the variable, which is delicon. And then we introduce the brackets, and then we go DC1, then we add DC2, then we add DC3, then we add DC4. I believe it's just those 4. Yes, it is. So once we are done with that, we divide by the number of items in the bracket, which is 4. Then we click OK. So as you can see from the screen, we have created 5 new variables, which are composite versions of the variables that we have in the AMOS file. So with these variables, we are going to go ahead and run the correlation matrix so that we can get the correlations to build our discriminant validity table. Now, in building this, we have to make sure that the changes we have made are saved into SPSS so that they will reflect in AMOS. So we click the floppy disk here to save. And as soon as we click it, you will notice that the disk becomes inactive. And once we have done that, we can now go ahead and test the correlation. So we go to Analyze. We go to Descriptive Statistics. We go to Descriptives, I believe. Then we put the items that we are interested in correlating into the variables box. So these include secupriv, order return, repurchase intention, timeliness of delivery, and then delivery condition. And under options, we want to see all the things that have been checked, right? And we don't really need anything else except for perhaps the variance. Then we click continue. Then we click OK. I believe this should give us the correlations. If it doesn't, we have to go back to frequencies. Okay, it didn't. So we have to go back to frequencies, I believe. So that will be analyze, descriptive statistics, frequencies. So in the frequencies table, we will basically do the same. We will enter all the composite variables we have created into the variables box. So that includes the secupriv, order return, repurchase intention, timeliness of delivery, and delivery condition. Then under statistics, we select standard deviation, minimum, maximum, and then variance. Then we click continue. Then under charts, we do not really need any charts, so we cancel that. We do not need to put it in any particular format, so we leave that alone as well. And we also do not really care much for style and bootstrap here at this point. So now we go ahead and click OK. And as soon as we do so, it produces a set of tables for us, which should include the correlation table. Wow, it doesn't once again. Oh yeah, sorry. So we are supposed to actually test for correlation. No one saw that. No one saw that. Are you following?
Yes, please, Doc. I realized that. I realized that
No
we
one
have to
saw
do the test correlation.
So we rather click analyze and then we go and correlate, right? And we are interested in bivariate correlation. So we go to analyze, correlate, and then bivariate. So as soon as we do that, we have to enter the variables as usual into the variables box, and it includes all the composite variables we have created. So we select all of them and put them in the variables box. And here the correlation coefficients have already been checked for us, which is Pearson, which is what we are interested in. And then the test of significance is two-tailed, which is what we are also interested in. And it will also flag significant correlations, which we want it to do. So here we are all okay. So we click OK. And as soon as we do so, we get the correlation table that we have been looking for. So this is the correlation table, right? And you can see it comes with a lot of things. So we have to copy it and then go and edit it by removing those parts of the correlation table that are not relevant to us. So we right click and then we copy. And then we go into Excel. I like to do it in Excel mainly because of the fact that it makes it easier for us to categorize and place all the items. So I'm opening a fresh Excel spreadsheet. The Stat Tools package is not to be messed with, mainly because of the fact that it is pre-programmed. So anything that you even change in it, like this particular thing that we have done here, the moment we close it, it will ask us to save. We are not supposed to save. So make sure you never save anything that you do in the Stat Tools package. Otherwise, it will mess with the formula that has been computed in it. So we will paste what we copied in SPSS here in this fresh Excel spreadsheet. So I'll right click and then I will paste. And it will paste everything here for me. So essentially, this is the correlation table. And we are now going to edit it to suit our objectives of computing the discriminant validity. So first, what we will do is get rid of all the things that we don't need, starting from this row. So I right click and then I delete this row. Then we are also going to delete all the two-tailed rows and the n rows. So we click, we right click, then we delete. We select, we right click, then we delete. We select, we right click, then we delete. We select, right click, and then delete. We keep doing that until we have arrived at just the correlations between the items being shown. So we right click, we delete. We right click, we delete. We right click, and then we delete. We right click, then we delete. And we do the same for the last two sets of items. We right click and then we delete. Then we delete the column that says Pearson correlation. We delete that as well. Now you will see that off the bat, we have a whole correlation table with a mirror image in the middle. Do you see that? So the middle row is all ones. Please, can you see that? Here, 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 and here. So whatever is above the diagonal is the same as what is at the bottom. Can we see that? Are you there?
Yes.
You can see. Yes.
Okay. Okay.
Yes,
Thank
we're
you.
there. We can see.
Thank you. So we are going to delete what is at the top part because we don't really need it, right? In building our discriminant validity table, we don't need that information. So we will delete all the items up there, one after the other. Then we will leave what is at the bottom of the diagonal. Now we'll have to replace the diagonal elements with the AVE values for each of the variables. Now you can see the AVE values on the left and the diagonal elements on the right. So we are going to replace each of them. So the AVE for secupriv is what? 0.94 what?
6.
Good. Then we're bolding that so that it will indicate that this is the AVE. Now that of order return is what? 0.903, isn't it?
Yes.
Yes. So that one as well. We're going to bold in. Then that of repurchase intention is 0.957.
Yes.
So we bold in that one as well. Then that of timeliness of delivery is 0.898. Then we bold in that one as well. Then finally, that of delivery condition is 0.929. Then we bold in that one as well. So now we have all our AVEs on the diagonal, beautifully presented, right? Now, we now have to go ahead and use the rules that we use to test discriminant validity when using the correlation and AVE. And it says to be able to test the correlation and AVEs to explain discriminant validity, we have to make sure that we find the square root of the average variance extracted and look at how it compares with the correlation coefficient, or vice versa. We square the correlations and compare them with the AVEs. So which one should we do? Should we find the square root of the AVEs, or we should square the correlations?
You should find out the square root.
So we should find the square root of the AVEs.
Yes.
Great. So please take out your calculators. Desmond, your hand is up.
Doc.
Yes.
Doc, I believe that the diagonals we have placed there, the values they are from the CR rather than the AVEs.
Really?
From the Excel sheet, yes.
Oh yeah. You are right. Thank you. So please, let's quickly fix it. Okay, Desmond, you said you are lost. Where did you get lost, please? Amosi, you said you are lost. Can you please tell me where you got lost? Oh, just what he said. Oh, okay. Okay, so we were replacing the diagonal elements where the ones are with the AVE values so that we can compare them with the correlations to see if we have satisfied discriminant validity. So,
so that means we didn't do that, no, because the AVE figures are different.
Yes, so we were actually copying the wrong figure. Thankfully,
Okay.
thankfully, members are paying attention. So we have realized. So we have to now put in the actual AVE values. So let's quickly fix them. The AVE for SecuPriv is what? 0.777, right?
0.77.
Okay.
Yes.
And then that of order return is what?
0.699.
And then that of repurchase intention, please. 0.91.
Yeah, 917.
Great. And then that of timeliness of delivery is
0.7.
0.745.
745. Great. And then that of delivery condition.
Oh, okay. And that one is
0.769.
Great. 0.769. Good. So now to test discriminant validity, we either have to square the correlations or find the square root of the AVEs. So which one should we do? I believe we agreed to find the square root of the AVEs. Is that what we agreed to do?
Yes, Doc.
Good. So then we have to take out our calculators and start calculating. So first we'll check what's the square root of 0.777. Square root of 0.777. Okay, so the square root is 0.881. Then we find the square root of 0.699. That is 0.836. Then we find the square root of 0.917. And that is 0.957. Then the square root of 0.745. That is 0.863. Then the square root of 0.769. That is 0.877. Please, are we all on course thus far?
Yes,
Are we
Doc.
all there? Good. So how do we check for the discriminant validity? We said that the diagonal elements, which are the square root of the variance shared between the constructs and their measures, which is AVE, and the off-diagonal elements, which are the correlations among the constructs, have to show a difference such that the square roots of the AVEs should be larger than the off-diagonal elements. Meaning that the smallest AVE should be bigger than the largest correlation. So very quickly in our table, what is the largest correlation? Okay, that would be 0.693, isn't it?
Yes, please.
Good. And the smallest AVE square root is what? 0.836, isn't it?
Yes.
Good. So in that regard, we have satisfied discriminant validity because all the off-diagonal elements are smaller than the elements on the diagonal. Am I making sense?
Yes, please.
Yes, Doctor.
Good. So this is how you present it. If you were writing a paper, this is how you will present it in table form, right? Some researchers would want to add the means and standard deviations for each of the variables. So you can also add that as well as two separate columns on the side or two separate rows below. But this is how you present it with the footnote, explaining that the off-diagonal elements are less than the elements on the diagonal. So discriminant validity has been satisfied. Now, this is a long process that we went through to generate the discriminant validity table using the funnel and Lacka criteria. However, there's one plugin in AMOS that can do it with one click. So let's go to AMOS and look at that plugin that is able to do that. Now this plugin is called the validity and reliability test. So you go to plugins, you scroll all the way down through your plugins and you locate validity and reliability test. Now, as soon as you locate it and you click on it, it will generate not just the funnel and lacquer table for you, but it will also generate the HTMT table to help you test for discriminant and convergent validity. So I have gone to plugins, I have scrolled down to validity and reliability test, and then I'm clicking on it now. Now, as soon as I clicked on it, it gave me a prompt. It said the observed variable seqpriv is represented by an ellipse in the path diagram, meaning that the name is not being recognized by AMOS. So I have to modify the name a little bit. So I click OK. And AMOS is telling me it can't find the plugin. It has an error running the plugin. Okay. So I'm going to fix the name of the variable. So let me remove the V and close it and save and see if it will run this time. Still not running. It's flagging all the other variables. Okay, so I'm going to keep fixing it until it has flagged whatever it will flag, then it will run. Okay, so it's moved on to the next one. Okay. Okay, so I have modified the names of all the variables and I'm going to run again. Great, this time it has run. Perfect. So please, whenever AMOS flags something, don't be in a hurry to just give up. Just read what it is telling you to do and try to find a solution to or fix it. So when AMOS says it has run the validity test, it will usually open a separate window where you will see the results of the validity test. However, I cannot find this window, which I find strange. Great, it has opened now. So it will usually open in a browser, okay? So this time it's opened in Google Chrome, since that is my default browser. So as you can see, it has built the tables for us. Do you see? Do you see that?
Yes, sir.
Good. Now look at the table we built manually by hand and look at the table that is generated automatically, the validity table. Do you see how the things are identical? Do you see? Look at the AVE values in the diagonal. Very good. They are virtually the same. So you will arrive at the same outcome if you do it manually or you do it with the plugin, right? However, like I said, the HTMT table is more difficult to generate using manual means. So the plugin is very helpful to use in generating the HTMT, because if you decide to do it manually, it will take a long period of time and it is tedious, right? However, you can be able to easily do it using the plugin. However, for those who want to do it manually, the steps are very well detailed in the SEM-made easy book. So you can take your time and look at the steps and go through it in Excel. Great. So now that we have satisfied reliability and validity, we can now go ahead and test our hypotheses. So if you are going to use this in your work, you will now copy these into the relevant tables. You will notice from the slides that I gave you that at every stage, there are tables that you have to build and specific items that you have to fill them with. So these tables give you all the information you need to fill in all those tables that are presented in the slides. Sumani says, would it have been same AVE values if the squares were used instead of the square roots? No. We found the square root of the original AVE value. So if we were squaring, we will not square the AVEs, we will rather square the correlations. So it's an either or situation. You either square the correlations and leave the AVE values alone, or find the square root of the AVE values and leave the correlations alone. You can't do both. So Mani, I hope you understand now. Okay, great. So now that we have satisfied convergent validity, we have satisfied discriminant validity, we can now go ahead and test our model, right? Good. So how do we test our model? We have to get rid of all these different covariance arrows to be able to make way for path arrows, right? So we use our X to delete the covariance models, all of them one after the other. Then we move the items around to create our framework. So currently it is in portrait, right? Currently it is in portrait format. So we are going to turn the layout into landscape so that we can be able to draw our model and spread it out. So again, I go to view, interface properties, then I change it from portrait to landscape A4. All right, so now it is in landscape. So I can now move things around and draw my model. So our dependent variable is the repurchase intention. So I'm going to select all the repurchase intention items and move them to the side. So I select all the pivots, right? And then I use the moving red car to move them to the side. Now I want the observed variables to move to the right side of it. So I will use the circle to rotate the indicators. So I click on the circle and I come and click on the latent variable and I move the indicators to the other side. Good. So I can use the car again to do some movement to make sure that everything fits exactly well on the sheet. Great. Now I'm going to position my independent variables, right? Starting from security and privacy, which is supposed to be my mediator. All right, so I'm just going to move it like that by selecting all the pivots and then using the car to move it to where I want it to be. And I want the measurement items to be above. So I'll use the circle to move the indicators and place them above like that. Then I'll deselect all of them using the fist. Then I'm going to do a similar thing with these items and move them onto the white sheet. So I'll select all of them using their pivots. And then I use the moving red car to bring them onto the sheet, like that. Great. So now that I have moved them, I have to go ahead and indicate my hypotheses. Now from our model, I have different items that I am going to use to test my hypotheses. And as we can see from the model, there are various relationships that we have hypothesized. Okay, sorry about that. All right, so these are the hypotheses we are testing. So we are testing the relationship between order return handling, delivery condition, timeliness of delivery, and security and privacy and repurchase intention. And then we are also testing the effect of security and privacy on repurchase intention. So we have to draw arrows to represent all of these. So we use the single-headed arrow up here. We click on that and we come to the model and we start drawing our arrows. So we go ahead and we click from order return to security and privacy, timeliness of delivery to security and privacy, delivery condition to security and privacy. Then we do the same from order return to repurchase intention, timeliness of delivery to repurchase intention, and then delivery condition to repurchase intention. Then we go from security and privacy all the way to repurchase intention. Now it looks like a mess. So we use our magician's wand to clean everything up and make it look pretty. So we click, 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 and everything looks nice. Please, are we all there?
Yes, please.
Good. However, we are still working in the CFA model, and we do not want the situation whereby we will edit it and then we will want to go back to our CFA and make changes, and we don't have the CFA model anymore. So we have to save this as a new model. So we'll go to File, click Save As, and then we will save it as on PA, right? PA meaning path analysis. So I'm saving it in my UGBS 703 folder and I'm calling it on PA. So then we save. So you will notice that immediately the name of the document changes to on PA, meaning that we are now working in on PA. And as soon as you go to the bottom of the screen where my cursor is hovering, you will see two different files, on CFA and on PA. So when I click on CFA, you see that the CFA model that we had previously is there, untouched, perfect, in case we want to go back and pick up from where we left off at the CFA. And then when I click on PA, the PA model that we built is also here, looking beautiful, meaning that we can go ahead and do whatever we want to do with this, such that if we make a mistake, we can always go back to our CFA model and pick up from there. Please, I hope you understand.
Let's go.
Good. Now, before we can go ahead and run the analysis, we have to tell AMOS which ones are the independent variables and which ones are the dependent variables. So how do we do this? We need to assign unique variables to each of the dependent variables to let AMOS know that these are our dependent variables. And the dependent variables are all those variables that have arrows pointing to them. And in the case of our model, there are two variables that have arrows pointing to them. They are in the form of what? Which variables are they? Which variables have arrows pointing to them? Yes, Desmond.
Secupre and rep in.
Very good. So we are going to assign unique variables to them. So we go up here next to the double-headed arrow. There is a box with a white circle on top of it. When you hover over it, it will say add a unique variable. We click on it, then we come and click on Secupre and rep in. So we click on them once, and as soon as you click on it, you will see that it will create new unique variables for each of them, right? So we go back and then we uncheck that icon, and then we come and name these unique variables. So to name them, we go to plugins, and then we select name unobserved variables. So plugins, and then name unobserved variables, and immediately it will name them. So you can see it will continue the naming from the value of the last error term. And the last error term for each of the measurement items is E23. So you can see that it continues by naming them E24 and E25. Please, can we see that?
Yes, please.
Good. So now
Yes,
our hypotheses are ready to be tested. So we will go back to our analysis properties to tell AMOS what kind of analysis to run for us. So we click that piano icon with the colored boxes on it. Then we come and uncheck the modification indices because we don't need it anymore. We uncheck sample moments because we don't need it anymore. We uncheck correlations. We don't need it anymore. We can leave covariances, and then we can leave the standardized estimates, the squared multiple correlations, and the minimization history. Then we close the box, and then we go and run the model using the piano keys that do not have any colored boxes on them. So we click on that, and AMOS will immediately begin to think. However, AMOS is telling us that there are some items that are not covariate, and that is because any item in the model that is not a dependent variable has to be covariate. So we have to cancel the analysis and go back and covary the items that are not dependent variables. And here, the items that are not dependent variables are which items? Can we quickly identify them? Which items are not dependent variables?
deadly, core, time D, and odd rates.
Very good. So we have to covary them. So what do? We select them using the finger that is pointing. We select odd red, time D, and delico. Then we go to plugins. Then we click draw covariances down here, as you can see. As soon as we click on it, it will covary all of them for us beautifully. Then we use the straight hand where the fingers are not folded to uncheck, right? Sorry, we use the fifth to uncheck everything, right? So now we have covaried. Now we are free to go ahead and run our analysis. So we go to the piano keys that have no colored boxes on them, and then we click on it to run. And as soon as we click, voila, it has run. It didn't give us any notification. So we go to output to see what the output is. And what is the output saying? We go to estimates. And again, we see the standardized regression weights table, which will tell us the significance levels of all the relationships that we just tested. And then the standardized regression weights will tell us the actual standardized estimates that we are going to put into our hypothesis table. So essentially, the information that we are seeing right now, we will use in filling this particular table. Oh, I thought I had a hypothesis table in this. Hold on, I'll open an article and then we can use that.
Juna. Juna. And okay.
Great.
Money, please can you mute yourself?
Great. So this is the table I was saying we are going to fill, right? So this is our hypothesis test table where we are testing the direct relationships. So the values that we are seeing in this table, right, which is the standardized regression weights, is what we are going to put in this column here, where we have the beta. And then the t-values column here with the significance values, we are going to fill them with information in the CR column and the P column in the regression weights table. So you can see that it shows each of the parts that we tested, from order return to security and privacy, time D to security and privacy, delico to security and privacy, order return to repurchase intention, timeliness of delivery to repurchase intention, delivery condition to repurchase intention, and then security and privacy to repurchase intention. And here you can see which of the relationships are significant and which ones are not. So order return has a significant effect on security and privacy. Timeliness of delivery has a significant effect on security and privacy. Delivery condition has a significant effect on security and privacy. Order return handling has a significant effect on repurchase intention. Timeliness of delivery, however, does not have a significant effect on repurchase intention. That's an interesting finding, because you would think timeliness of delivery is key in people deciding to repurchase from a particular retailer. Delivery condition, however, is a very significant predictor of repurchase intention. However, security and privacy is not a significant predictor of repurchase intention. Hey, that's another interesting finding, right? So of all our hypotheses, in total, we had 7 direct hypotheses. 5 of them are significant, 2 of them are what? Not significant. So that is the information we will be putting into this table. So this is the table we will build. And we will tell the results based on what each of the parts were in terms of significance, based on which ones were significant and which ones were not. Good. So these are for the direct relationships that we have just tested. And when you go back to the interface, you can see that all the relationships will even be shown you in a snapshot when you click on the standardized estimates table. Great. Now, the squared multiple correlations is also important because it tells you how much of the variance in the dependent variable is explained by the independent variables that are predicting it. So the squared multiple correlation, or the R squared value, you know R squared from multiple regression, is the same as the squared multiple correlation. So here you can see that the R squared value for security and privacy is 0.66%, meaning that the three factors that were predicting security and privacy explained 66% of the variance in security and privacy, which is very high because the minimum threshold is 50%. The same for repurchase intention. You see that the factors represent 51% of the variance in repurchase intention, which is very significant and quite high. So here, the items that we are using to measure security and privacy and repurchase intention and to predict them are very reliable in terms of what we are using them to predict, right? So just like that, we have tested our direct hypothesis. Now we can go ahead and test for mediation. But before we do so, does anyone have a question they want to ask about where we are so far? Yes, Moro.
Thank you, Doc, for the great present. Because I am learning a lot.
Yeah, you're welcome.
Yeah. So I want to find out, because there are instances some scholars will go and rather bring the averages to form the structural model. So I don't know if that's also.
Yes,
yeah.
You can do that one too. So let's quickly try and do that. Hold on. So because when we did the composites, right, and we found the averages, we saved it in SPSS. It has been registered in AMOS. So when we click this part of the diagram, right, where it says title, next to it, you see it says list variables in model. And then next to that, it says list variables in data set. When we click on it, you will see that all the new variables that we created have been registered in AMOS. Can you see that? They are at the bottom. So we can draw a new model using these composites. Let me quickly demonstrate. So we go to file and we open a new document, because like I said, you do not want to mess with old things that you have done in case you want to go back and use them again. So it's asking us, since we want to create a new document, do we want to save this? Our answer is yes, so that it will keep the changes we have made to it. So now we have a new interface, right? And we are going to use the items in the data set to draw the new model, right? So we have opened a whole new data set altogether. So very quickly, I'm going to re-import the model. Sorry, the data file, right? Using the same procedure that we have learned. So as soon as I do that, the items will all be registered. So now let's draw using the composites. So we said security and privacy is one of our variables. You just click and drag. Then we have repurchase intention as our dependent variable. We click and we drag. Then we have order return as one of our independent variables. We click and we drag. Then we have timeliness of delivery. We click, we drag. Then delivery condition, we click and we drag. Now the same treatment we gave to the other items when we were creating the model, we will do here. So we use a single-headed arrow to determine our hypothesized paths. So we click the single-headed arrow, then we start the connection. So order return to security and privacy, timeliness of delivery to security and privacy, delivery condition to security and privacy, then order return to repurchase intention, then timeliness of delivery to repurchase intention, then delivery condition to repurchase intention, and then security and privacy to repurchase intention. Then we use our magic hand to clean things up before we do the rest. So just like we did in the other model, we said the dependent variables have to be identified so that AMOS can know that they are dependent variables. So we give them unique variables to identify them. So we click on that rectangle with the white circle on top of it. Then we come and create unique identities for our dependent variables by clicking on them. Just like that. Then we go to plugins and then we click name unobserved variables so that these new unique variables we have created can be named. As soon as we click on it, they will be named. Since there are no other existing error terms, it will start from 1 and then proceed from there. So now that we have identified our dependent variables, we now have to go ahead and identify who are the independent variables. So everyone who doesn't have a unique variable has to be covariate to show that they are a dependent variable. So like we did in the other model, we use the finger pointing to select all the factors that are going to be covariate. And then we go to plugins, and then we select draw covariances, and it will immediately beautifully covariate all of them for us. Then we use the fist to deselect everything. Then we have built the model. Now, because this is a new model altogether, we have to go ahead and save it before we run anything on it. So we go to File, we click Save As. Then as usual, I'll save it in my UGBS 703 folder. And I'll name it Comp PA, meaning that it is the path analysis model that I built using the composite versions of the variables. Then I click Save. Then I will close it and go back and reopen it. So I'm going back to reopen it. I named it Comp PA. So there it is. I'm opening it now. And then once I open it, I am going to go ahead and run the path analysis that we run using the other model. So I have reopened it now, and I'm going to now determine the output I want to see. And like we said, we are interested in minimization history. We are also interested in the standardized estimates and the squared multiple correlations, and then covariances. So we close that, and then we run the model. Now, as soon as we run, the red arrow facing up is active, meaning that it has run beautifully. So we go to the output to see what the output says about what we just ran. And just like in the other one, we go to estimates and we look at the regression weight. Now you can see, because we are using composites, the particular items that measure each of the variables is no longer showing in the regression weights table. Can you see that, Moro?
Yes, please.
Good. It is only showing us the composites. And as you can see, it has given us basically the same results. Do you realize?
Yes.
Out of the 7, only 5 are significant, and the other 2 are not significant. And the 2 that were insignificant previously are still insignificant here. Only that there are slight variations in the measures. You see that? Aha. So it's the same thing. It's a matter of preference. I prefer using the other model with the latent variables and the observed variables all together. But using the composite versions of the variables gives you a clean interface, right? And you are able to see things more clearer, and you are able to move things around more easily. But they will both give you the same output.
Okay. Yeah, thank you very much, Doc.
Great.
Yeah.
All right then. Any other question before we go ahead and test our mediation? Any other question? Okay.
No, please.
Okay, so now let's go ahead and test our mediation. So for the fun of it, let's stick with this model, right? So in testing for mediation, you need to do what we refer to as bootstrap, because that's a lot of the scholars in the area will tell you. The other techniques for testing for mediation have issues. For instance, the Sobel test, which was one of the techniques that was previously used, is considered to be flawed. And the Baron and Kenny approach, which was also previously used, has been disputed and also considered to be flawed in some ways. So right now we are all heading in the direction of bootstrap, which helps us to be able to get the power to be able to generalize our findings and get more accurate results from our mediation analysis. So we are going to run a bootstrap mediation test right now. And we are hypothesizing that security and privacy mediates the relationship between order return handling, timeliness of delivery, delivery condition, and repurchase intention. So we are going to test that mediation right now. So we will go to the analysis properties. And here, under outputs, in addition to all that we are looking for, including the standardized estimates and the squared multiple correlations and the covariances, we are also going to test for the indirect, direct, and total effects. So we check that box. Then we go from the output tab to the bootstrap tab. And here we are going to perform bootstrap. So we check perform bootstrap. Now, when you're performing bootstrap, you need to indicate the bootstrap sample size that you want to use. Now, when it comes to bootstrapping, any sample from 1,000 to 5,000 samples is acceptable. So here we are going to use 2,000, right? I'll just add 10 to the 200 that is already there. Then you have to indicate the bias corrected confidence interval that you want to use. If you select a 90% bias corrected confidence interval, it means that you are saying that your output will be significant at a p-value of 0.1 and below. If you select a bias corrected confidence interval of 95, then you are saying that your p-values to indicate significance are from 0.05 and below. So here, let's use a bias corrected confidence interval of 95 or a bias corrected confidence level of 95, indicating that we will be interpreting our p-values from less than or equal to 0.05. So once we select this, we close the tab and then we go ahead and we run the model because we have already indicated which one is the mediator and which one is the independent variable and the dependent variable. So we quickly go ahead and run. Now, as soon as we do this, we don't get any dialog box indicating any information, meaning that it has been able to run successfully. So we quickly run to our output. And when you click your output window, you will see estimates once again. So we click the plus sign next to estimates. Now, as soon as you click the plus sign next to estimates, you will see that a new item has been added under estimates, which is scalars. So we click the plus sign next to scalars. And immediately you click it, it will show you what? Covariances, correlations, standardized regression weights, variances, and squared multiple correlations. Then you will see matrices. And as soon as you click the arrow next to matrices, it will show you total effects, standardized total effects, direct effects, standardized direct effects, then indirect effects, and then standardized indirect effects. What we are interested in is the standardized indirect effects because that is what is going to help us to test the mediation. So we click standardized indirect effects, which tells us the mediation coefficient for each of the items. So in terms of the mediation coefficient for delivery condition through security and privacy to repurchase intention is 0.037. Then that of timeliness of delivery through security and privacy to repurchase intention is 0.030. Then that of order return handling through security and privacy to repurchase intention is 0.049. So these are the coefficients of the mediation test that we have conducted. Now let's go ahead and see if the mediation is significant or insignificant to be able to tell if there is a mediation effect at all. And to do that, we come down to the next quadrant where we have estimates/bootstrap. Now over there, you can see estimates, bootstrap standard errors, and then bootstrap confidence. So we click the arrow next to bootstrap confidence. Then you will see it brings down a drop down that says bias corrected percentile method. We click the plus sign next to that, then you will see it drops down another menu that says lower bound, upper bound, and two-tailed significance. This is what we are interested in, the two-tailed significance, to tell us whether there is a significant mediation or the mediation is insignificant. So we click two-tailed significance and then we go ahead and check whether there's a mediation. Now, from delivery condition through security and privacy to repurchase intention, the value is 0.136. Is that significant or insignificant?
Insignificant.
Good, meaning there is no mediation. Security and privacy does not mediate the effect of delivery condition on repurchase intention. Let's look at the next one. From timeliness of delivery through security and privacy to repurchase intention. Is the value of 0.137 significant or insignificant?
Insignificant.
Excellent, meaning that security and privacy does not mediate the relationship between timeliness of delivery and repurchase intention. Now, finally, from order return handling policies to repurchase intention through security and privacy, is the value of 0.178 significant or insignificant?
Insignificant.
Excellent, meaning that security and privacy does not mediate the relationship between order return handling and repurchase intention. So this is the output of our mediation analysis. And come to think of it, this actually explains what happens on the ground in our context. Because when we look at the factors that we are studying, security and privacy on the ground really does not mediate the effect of these factors on a customer's repurchase intention. Ghanaian customers complain all the time about the rider being late and the retailers not offering returns, but they do not allow that to affect their repurchase intention. And Ghanaians always complain about being scammed, their information being stolen. But Ghanaians still go ahead and buy online, don't they?
I do.
They do, despite all the risk. So this output is basically confirming to us what is happening on the ground. And that is the beauty of applying theory to research. Because when the output makes sense like this, it's very easy for you to explain and justify and go your way. So ladies and gentlemen, we have done a hypothesis test of direct relationships, and we have also conducted a mediation analysis. Is it hard? Grace, be honest, it's not hard. It's not hard. It's not hard. It is because
No, if you understand, it's easy, but
thank
if
you,
you
Grace.
are learning.
Good. So right now you have learned it all. The next step is for you to practice. And I always emphasize this to my students. Data analytical techniques are a skill. If you don't practice, you will forget.
Yeah, sure.
So you have to make sure that you are, and the more you practice, the more you become dexterous with it. So as you are practicing, you are remembering some things. And another thing too about learning with software, you cannot learn everything like we are learning now. A lot of the things you will learn about it, you will learn as you practice with the software. So please, this one that we have done is just a primer. So AMOS, you don't worry at all. As soon as we finish, the video will be converted. I will share the video with Prince, and then you will make it available to everybody so that you can follow what we did and then practice. But please keep practicing. And then try and get your hands on other data sets as well and use it to practice, because every data set is different and they will all present you with different challenges. You will notice that the data set we started with was very challenging, but this one was very simple, isn't it? We didn't struggle at all. We just did a few modifications and we were able to get the valid items that we used to continue and run our analysis. Some other data sets may not be so simple. You may have to end up eliminating some of your variables. And if unfortunately the variable that is not doing well in terms of satisfying reliability and validity ends up being your dependent variable, it means your entire framework has fallen apart. So I always tell people that quantitative data analysis and its success or failure begins right from when you are designing your questionnaire for data collection. Make sure that if you are designing a questionnaire to collect primary data from scratch, you design it using well-established skills that are bound to give you good data for your analysis. If it is panel data, make sure you are getting it from a reliable source so that when you start analyzing, things will not start falling apart and then you become confused. And then it's the last minute, you've already gone to the field, you can't go again, and then you are in a fix. Please, I hope you all understand.
Yes, Doc.
Great. So please go back and practice. And while you are practicing, if you don't understand anything, WhatsApp me, call me, text me. We can think through it and help you to solve the problem, right? So please don't go and close the books and put the video somewhere and relax. Please go and practice so that you do not forget. Awesome. Moro, your hand is up. Always a pleasure, Grace. Moro, your hand is up.
Yes, please, Doc.
Yeah.
Yeah. So I was asking, like, maybe for instance, can you go through maybe a literature and theory and develop your own skill by taking them through exploratory factor analysis, so,
Yes.
so that if the indicators are good, you use it.
Very good. That's why piloting is important. Yes, Moro. I did it myself during my PhD because the variables that I was testing, I couldn't find reliable skills for. So I had to do a pilot test with the skills that I was building to see those ones that will stay and the ones that will fall apart. So pilot testing is important. And as soon as you do that, you realize that the variables that you end up with will be solid. And then when you use them for your main study, you are good to go.
Okay.
Yes.
Yeah, thanks very much, Doc.
My pleasure, Moro. Awesome. Anybody else? Oh, we're good.